Hello, this is Mr. Stansbury. I'm going to take you through the notes on the sine and cosine functions. At the end of this, you should be able to say, I can recognize and graph basic sine and cosine functions. Okay, so we're just going to get straight into some examples and look at the difference between sine and cosine here. Okay, so example, use the x-coordinates of the points on the unit circle at intervals of 45 degrees to create a table of values for sine of theta. So this is our sine graph, and then graph the function. Okay. So if you remember a couple sections ago, we went through and we filled in that big chart about the unit circle. We basically were getting all that information and just copying it into here. Okay. So sine theta at 0 degrees is 0. So here's 0 degrees. Here's 0. So let's put that in there. At 45 degrees, so here's 90, so halfway between there is 45 degrees. It's root 2 over 2. So we're just going to graph a bunch of these here. So first, let's figure out what root 2 over 2 equals as a decimal, just to make ourselves make it a little bit easier on ourselves. Okay. So we will turn this on. Hopefully, it will turn on. There we go. So we do root 2 equals, and then divide by 2 gives us 0.71. Okay, so 45, let's see, this is 2, 4, 6, that's 8, so we're about halfway in between here. There's our 0.71. And then at 90, we're all the way up here at 1. 135, we are at root 2 over 2, so we just figured out that that is 0.71 roughly. And then back at 180, we're down at 0. Okay, and then 225, now we're at negative root 2 over 2, so that's going to be negative 0.7 about. And then at 270, we're at negative 1. At 315, right here, we are at negative 0.7. And then at 360, we are back at 0. Okay, so create a table of values for sine and then graph the function. So you can tell right here that this is creating a bit of a rounded graph. It's not a zigzag graph, but a rounded graph like so. Okay. Now, something else is we can actually continue this on. Oops, I did not continue that on long enough to get to the 360. And then we can actually continue this on. We don't need the table because this is a periodic function. Pretend that that line goes through that point right there. It's a periodic function. So what's going to happen right here is this is just going to repeat. Okay, so over here we're going to go up to 0.7, 450. We're really just copying these points, just moving all these points over 360 degrees on this scale here. Okay, that's 0.7. Right down here we're back at 0, and now we're down at 0.7 again. Down here at 0. So these are negative 0.7s, and then that's negative 1 and back at 0. So then we can just kind of continue this graph up here to come down. We make a nice little graph here. So this here, this is the sine curve. Officially, y equals sine theta is what you'll see it written as. Okay. So real nice little basic. Notice it goes up to 1 and down to negative 1. Okay. We're going to also take a look at the cosine curve. But before we do that, let's take a quick little comedy break.
Yeah. He can't get it. Yeah. Hey! Where's my glove?
Okay. Let's take a look at the cosine curve. Okay. So use the x-coordinates of the points on the unit circle at intervals of 45 degrees to create a table of values for cosine theta, and then graph the function. Okay, so at 0 degrees, we're actually starting up here at 1. At 45, we're at root 2 over 2, which we figured out is 0.7. And then we're at 90, we're at 0. 135, we're at negative 0.7. 180, we're at negative 1. 225, negative 0.7. We're just going to kind of keep going through and finding all these points here. 315. We're back up here at 0.7. And then 360, we're back up here at 1. Okay, so if we graph that, oops, a little bit of a struggle there. Here we go. So we go down, and then it's going to kind of curve up again like that and kind of come up here and flatten out. So there's our cosine curve, right? And then again, if we want to draw that farther out, we could just keep repeating these. This is a periodic function. This is just going to repeat. So I know that this next one over here is going to be right here. And then the next one, if I'm kind of going basically just kind of like a little mirror image. And then this next one would be down here at 0. And then at negative 0.7, negative 1, negative 0.7 again. We're back up here to 0. And then at 0.7. And then back up at 1. Okay, and then we can draw those through there. It's supposed to be a little bit more curvy, but you get the idea. Okay, so in like summary here, our sine curve is going to look like this. So y equals sine theta. If you'll remember, we went from 1 to negative 1 up to 360, and we have these little points here. We started here at 0. It went up to the top here, back down to the middle. It looks like this is our sine curve. And then y equals cosine theta is this one right here. We started at 1. Let's say the 360. Cut those up into quarters here. And remember, it went down here at 90. It was at the bottom at 180, back at the middle at 270, and back, oops, a little too high there, back up at the top at 360. So here's our cosine curve. And really, actually, these are the same curve, just with a little bit of a shift. Okay, so if you picture it right here, look, from here, I'm going to try this out, from here up, down, and around like this here. Look, that's just the sine curve. Okay, just shifted over. Okay, and on a sine graph, just like what we had back here, look, from here, oh nuts, from here over to here, this is our cosine curve. So really they're the same. Not sure why that's not drawn in there. Oh, probably because I'm on the wrong layer, but you get the idea. It's the same. It's our same little curve here. Okay? All right, that's all we have for sine and cosine functions. If you have any further questions about any of this, please feel free to ask. Thanks.